Helm's Deep, and he really looked at the trees, okay? I'm going to talk about the geology of Helm's Deep, but I want to look at the forest. So I have a more broad overview. I don't go into the same detail that he does, and I disagree with him on some things and agree with him on others.
Yeah, you could, but you won't.
Let's see. So, at one time, not too long ago, most of Tennessee's longest caves, the ones that were between 18 and 40 miles, were all right around the Cumberland Plateau, right? That's where all the big caves were. Nobody wanted to look for any caves here. There's nothing there, right? But that changed, right? So the enigma, I'm calling these enigma numbers, is why is the longest cave here? Okay, why is there a 60-mile long cave system here? That's kind of an interesting question. Part of the reason is probably because all the really nice, sexy limestone that you get in this part of Tennessee is gone here, okay? So the cave development is very different. So you're talking about, you know, apples and oranges when you're looking at the cave development on two different sides of the state. So why is the Western Highland Rim, where most of Tennessee's most prolific cave-forming limestone? Well, that's why, because all of the limestones that we see everywhere else are gone down here for whatever reason. And I don't know the reason. I'm not going to claim that I know a lot of things. I don't know a lot of things, and that's what we're going to talk about. So, enigma number 2, is this a map, a result of the 70s survey, or is this kind of like a one from mind-altering substances? Because this does not look anything at all like the cave. I mean, not even remotely. And I know survey standards have changed, but I don't know if they've changed that much. So anyway, that was our second enigma there. Okay. So currently, as you all know, Helm's Deep is 66 miles long. If you like metric, it's 106 kilometers. That sounds a lot bigger, so we're going to go with kilometers. And then vertical extent is, we're going to call it 187 feet because 57 doesn't sound like much. And so I'm showing the cave in two different views, and I'm going to look at these shapes in a little more detail. So Helm's Deep does not fit the model of caves that we're used to seeing in Tennessee, right? We're used to seeing the plateau margin caves or the Cumberland style caves. You know, we are very familiar with that. Well, Helm's Deep is neither one of those. And so that's the other enigma. Why? And instead of being in those really nice, fat, wonderful limestones that we love, it's way down here in the lower Mississippian, in Devonian shales, and in Silurian limestones. That's kind of weird for Tennessee. That's not normally where all of our caves are. Does this even look karsty? This looks like there's no caves here. This all looks very, very fluvial. And so, you know, that's an enigma. You have this landscape that doesn't really give a clue about what's underneath it. I mean, we don't see a lot of sinkholes. There might be one sinking stream. However, there are some caves and there are some springs. So that at least tells us that, well, there's something going on there. So there's about 75 caves in Perry County, but they're not all concentrated here. Here's Helm's Deep. All of these blue marks are springs, but they're not all potential springs for this. That's the mystery, is where's the water coming out? If there are two really big springs, one here and I think two more here, could possibly be resurgences. So rather than saying we don't have any idea at all, I would like to say, well, we do have some ideas, and those are some of them. Now, what we don't want to do is wave our arms and say, well, we think this, blah, blah, blah. We're going to say we don't know, and we need to do more dye tracing. So, but I say that later. So, number 4, my enigma, is that Helm's Deep has two really, really distinct, like, layers, okay, or tiers. And one of them is this crazy maze, which you guys have already heard a lot about. And most of the length of the cave is here in this maze. And this is like 3 miles, north to south, and maybe 2 miles east to west. And all that maze is concentrated in there. So why is that? There's also a stream level, and I put some vertical exaggeration on this just so that it shows a little bit better, because normally it's going to be cramped up here and you can't tell what the relationship between the stream and the rest of the main passage is. So are they truly related geologically? That's one of, well, I guess that's everybody's question. And I'm going to say that I don't think that they are. I think it's pure luck that they kind of met here. And this is something that I think that I see often in tag, and in Tennessee, in specifically, is you get some really big borehole passages, and then you get all these little multi-level routes that lead into them. And those are two different phases of cave development. And I think you're seeing two different phases of cave development at Helm's Deep. So, now, I notice Christian likes to call this an anastomotic maze. And if you're wondering what that means, this is the shape of an anastomotic maze. Now, this is the cave plot with just the line plot. It doesn't have any passage dimensions on it as far as I can tell. So if you put passage dimensions on this, which this plot has, it doesn't look too, it's looking less anastomotic and maybe a little more networky. And so I think we need to survey more cave to figure this out. But I don't think you could say definitively it's one or the other. It seems to have a little bit of character of both. It's a maze. It's an amazing maze cave.
That's in Texas.
So as far as like, why do we even care about mazes? Well, the mazes in caves can actually give you some clues about what formed them. So what formed an anastomotic maze is a different process than what formed a network maze, and that's why the difference is interesting. So in general, if you want to say, well, what causes mazes? Well, you can get a lot of intersecting fractures. If you get a very joint-controlled cave, that's one way that you get a maze, and it's got all the water going in it at the same time. In an anastomotic maze, most of the water is coming in on bedding planes and bedding partings, so that's slightly different. Or you can get a spongework maze, which is what we don't have. And these are from very, very young limestones that have a lot of porosity. So we can count this out. That's not going to be what Helm's Deep is. So, the cave passage is an indication of how the water gets into the underground and how it flows through the cave. And so, as I said, I kind of explained high discharge along alternating routes, short flow distances between where the water comes in and where it encounters the limestone. And this is what's going on at Anvil Cave, if you've ever seen a little map of that. Anvil is only like a minuscule size is Helm's Deep. You can have uniform discharge among many competing flow routes, in other words, a floodwater maze, which is very epigene. Or you can get that what is dissolving the limestone in the cave already exists within the aquifer itself. So that means that you don't have to have deep water coming up and dissolving the cave. If you've got the right ingredients in your limestone and you got a bunch of water flowing in it, it could self-dissolve itself. And that's the one I kind of favor. So everybody, y'all are familiar. There's 3 different levels to the maze. There's a very shaly level, and you get these big shale-type boreholes in the Fort Payne, probably. This has got to be my all-time favorite cave passage. I can sketch in this for like hours. There's no detail. There's nothing. It's fabulous. You can just do this until you puke. This is wonderful. And then you get down to Mirkwood, and that's the lower maze, and it is extremely muddy. So you got to wonder, why is it muddy? And that might have something to do with the stream, because as you get farther and farther to the north, the cave seems to be getting at the same elevation as the stream. So that's a possibility. You have to account for these things. You can't just say, well, it's muddy, but we don't know why. It's like, think of some reasons why it might be muddy, and I think that's one of those reasons. And of course, the active stream level. So this is what the stream looks like in Helm's Deep. It looks like a freaking river cave. That's what it is. And then you got all this crazy maze stuff. The river cave, it sumps on both ends. I think Jason I think he dove the upstream sump, and from what I understand, it was not a fun dive. And you have all this active stream passage. And the thing is this stream passage, as Christian pointed out, it has no side passages. It's very linear. It's very straight. And when you have a passage that's shaped like that, that indicates that you probably have just very few or maybe even one point of recharge. Okay? You don't have a whole bunch of sinkholes that are feeding it. It's coming in from one place. And where might that one place be? And so, once again, I'm just reiterating, I'm getting a little bit ahead of myself, but there has to be some place on the surface where all this water is coming into the cave. And it's like a lot of water. It's not like a bunch of water that seeped in and accumulated. This stuff is flowing. And I've seen this before. Of course, I pirated this picture from Christian, I believe, or looks like Jonathan and Christian. And so this cave does flood. It doesn't flood maximally to the ceiling so far, but it does respond to weather in some way, so to precipitation. So you can't say that they're totally disconnected. So I would say that your fifth enigma is the hydrology, like what's going on. And so considering Helm's Deep is here, you've got the Duck River, you've got the Buffalo River, which are both tributaries of the Tennessee River, I would think that maybe, we know for sure that the Duck River loses water. That's like quantified, that's proven. No one has proven this for the Buffalo River, but it makes the most sense, even though it seems to be a distance away, that if you're going to have that much water in the cave, well, your point of recharge is probably going to be this river. And the river, how does it respond to precipitation events? So I think you can see that by looking at some of the staff gauges. But what we did was we installed a stilling well with a data logger in it, and then of course a surface weather station. So we'll know exactly for sure when it rains, when does the stream, if at all, respond to it. Because we only have spot checks on when the stream has or hasn't responded. And you really need to have series data. Like, I think I have this set up at a 10-minute interval. So for the next maybe 6 months, we can see how the stream responded every 10 minutes. And you might see a lot more detail than just looking at it like once every couple of months. That's kind of the hope. And with that in mind, before I go into the rocks, we are planning, and with Christian, to do a dye trace in the area. The first trace that was done is kind of a failed trace, and we're not exactly sure why it failed. I know that it rained a bunch, but for whatever reason, we're going to repeat it and more, and at the very least, try to figure out what is the recharge area, like where's the water coming from Helm's Deep. So of course, enigma number 6, what do the rocks say? You know, the rocks, you think, they're just rocks, you're dumb as a rock, right? You don't know anything. Well, these rocks have a lot of information in them. And by analyzing our rock samples, we believe that it's going to tell us a lot about how the cave formed, or the conditions that formed the cave. And so what we did was, it was Sid and I and one of my students, we started at the river, and we collected rock samples all the way up to the entrance. And so we haven't finished analyzing those yet, but I think that we have a real basic stratigraphic column, which is very similar to a Christian stratigraphic column, which is a good thing, right? We're agreeing on stratigraphy. And we're pretty confident about our calls of all the Silurian limestones. I think the really important thing is the Chattanooga Maury Shale thing. There's multiple disconformities there, and that means a place where there's an erosional surface. There's multiple erosional surfaces. You have all this maize concentrated in this area, and so this is probably like an inception point, or a place where that's where water started to get, to get into the rock to start dissolving cave. And so we'll clarify this better once we analyze our rock samples. Now, the cave mineralogy is going to be really important. And I don't have any pictures of speleothems. That's all cave cancer. I'm not into that stuff. But the mineralogy is really important because it does tell you a lot about the conditions that form the cave, because that's the stuff that's left over. So we know for sure that the Fort Payne, the Chattanooga Shale, and the Maury Shale, they all have pyrite in some form or another. And why is pyrite important? Because if you oxidize it, you can form sulfuric acid. And what does sulfuric acid do? It forms cave. So this does not have to come from some deep source underground. When you say the word hypogene, oh my God, hypogene, it doesn't just mean one thing. It's kind of a big basket for a lot of different ways that you could form cave that's different from water coming in from the surface. And so I think that that's what's going on at Helm's Deep. There's also been hydrocarbons reported in the Chattanooga Shale and in Fort Payne. I think this is why Christian tried to set this stuff on fire. He thought it would be fun to like burn rocks or whatever. If you know Christian, you'll be like, yep, that sounds like something. And then there's various forms of gypsum. There's some outrageous, pretty spectacular gypsum speleothems, which I'm not going to show you any of. However, what's really cool is that you get these really big gypsum crystals that are in the mud. And it's like, that makes no sense at all until you realize that this gypsum and this gypsum are basically formed in two different ways. And the way that we're going to tell those apart is by doing some isotopic work on that, which we haven't done yet. But you can get gypsum that forms like stuff in Mirkwood, and it results from the oxidation of sulfides by calcium-rich groundwater. So ta-da! So now we're coming up with our source of what might be dissolving in cave. And it's all self-contained into that shale and limestone rock unit. We also, as also Christian mentioned, we were all in one of our labs and playing around. As a matter of fact, Will was the Raman spectroscopy guy. And we were saying, look at this, and he was just randomly looking at stuff. And we identified some things. And what we identified, and I got all excited about this, was because some of these things have to do with forming cave in shale. They're like a residue for how you could form a cave in shale. Okay, because normally, as you know, we don't get caves in shale. But we see shale-type passages in Helm's Deep, so we're thinking that those are probably some little smoking guns for that. And of course, there's that dang snotite. The reason it's called a snotite is because what does it look like? That's what it looks like. And so Louise Hose saw a picture of this in one other presentation, and she said, what's the pH of this? Of course, none of us had any pH paper. We didn't take pH. But we're pretty darn sure that there is microbial influence in the cave. For sure in the speleothems, and maybe possibly in speleogenesis. But that's an area that is kind of wide open, and no one's really looked at that. But certainly the possibility exists from all these crazy gooey coatings that you see in the cave. They all look very organic. So, enigma number 8. The maze seems to be completely out of sync with the current landscape. The way that the landscape is now, there's no way that it formed a maze. So what does that mean? Did aliens come down and form the maze and leave? Or was there another reason maybe that it formed? And I think what you have to do is you have to step back even from looking at cave development and look more at your geomorphic development of the area, and then you're going to start to see that, and I have all this writing here, but what I really, really mean to say is the landscape is always evolving, and it is influenced by surface and subsurface streams, and these guys interact. So whatever it was that formed that maze initially does not exist anymore, okay? The landscape has completely changed, and that's why it seems out of sync. One day it was, or one time it was, now it's not. The stream passage is in sync. That makes sense for the surface conditions now. So that's why I'm kind of the school that you have two different events that formed cave passage, and these cave passages, just happen to intersect each other for pretty much. So is this a hypogene cave or is this an epigene cave? And if you don't know, hypogene means that the acid that dissolves the limestone doesn't come from surface water. It comes from somewhere else. And somewhere else, there's many different somewhere elses. So that's why rising waters is only one, and that one doesn't make sense for here. So I asked Art Palmer this, who's kind of like the king of mazes, and he says, you shouldn't agonize over these classifications because they're really not all that important. What's important is that you describe what you see and you quantify it and go with that. And so basically I think that what we can say about Helm's Deep is that it's a polygenetic cave that displays multiple phases of speleogenesis. So we're not going to call it hypogene, we're not going to call it epigene. We're going to say those processes were active at one time or another, And I think that's a lot more useful way to understand the cave rather than try to classify it as one or the other. And then of course, my last enigma, are we suffering from exploration bias? Exploration bias means that you only go look at places where you think things are going to be. And so where everybody's been looking for years and years, caves are where you find them. And so maybe there's other Helm's Deeps or other interesting things in the area that right now we're not looking. And so, let's see. This is my only Speleotham. I thought it was a cool picture. Compliments of Corey Sand. He gave me a whole bunch of really cool pictures to include. And this is, I like all this sediment here much better than this. So that is the end of my talk. Let's see how much time. Oh, I actually have some time. Does anybody have any questions?
Hey PK, awesome talk. Sediments on the ceiling. Do you know what they are, and what kind of opportunities are there for geochronology?
Well, so some of that jarosite is part of the alunite series, and alunite is used to date things. So we think that might be a way to get a geochronology, like an age of the cave or the sediments. Also, I think that condensation corrosion is really important in the cave. And what condensation corrosion means is that your air, which has a lot of moisture in it, which is also slightly acidic, that also dissolves cave, just like water dissolves it. So it's just a slightly different medium, but it's both dissolving cave. And I think that you see that in Helm's Deep because you see all these really smooth ceilings and you see all these very fluffy sediments. They don't look like sediments that were left by a stream. They look like sediments that came off the ceiling and then just fallen to the floor. So, yes?
I guess a couple, but one great job. The thing is there any overlying or underlying material where the cave can get much deeper vertically, or is this kind of constrained?
Well, are you talking about which part of the cave? Because you have your maze,
Yeah.
and the maze looks like it's pretty much constrained to that unconformity, disconformity. Now it looks like at one point that the river, the active river part, and the maze may actually end up at the same elevation, which might explain all the mud in Mirkwood. Maybe.
And then the other question is, as you say, there may be a lot more quotes Helm's Deep, but as that one standard kind of reference book on cave says, how many of them actually have entrances on the surface that you can therefore get down into the underlying cave?
Yeah, just think of all the caves that are there that don't have entrances.
Right, exactly.
There's many, and you can see that example. If you ever come to Mammoth Cave, we have lots of cave there, but we have ridges that have no cave in them at all. Not because there's no cave in them at all, but we haven't figured out how to get into them. And I think you can say that in a lot of places. So we're never going to run out of caves. Who else had questions? I can take one more.
Jim.
Okay, Jim.
One thing that has not been discussed are the scallops.
Well, I was going to ignore those, and I was hoping that you would say
It may be part of that.
Next question.
But I think you're right.
The river did flow through there.
Well, what we were wanting to do is go look at those scallops, Jim, which I was hoping you'd give a tour, take me to the scallops, and just kind of maybe see how many, quantify the scallops. Because they are important, even though I did mention them. This is preliminary work, so good point.
Additional questions?
If anybody has any other questions or you want to disagree with me, come and find me. Come and catch me if you can.
Thank you,
I
Dr.
truly have to go to
Kambesis.
another talk.
That was great. She's got to give another talk. She's not blowing us off, honest.